I think that's a gas powered plane. And so big planes, big
That's
planes.
actually how big it's going to be for our UAV.
It's going to be pretty tough to. You're going to be spending a lot of money for batteries to get something like that up for any length of time. The other question is how long do you think you need to keep it airborne after you get it up? Because that's a big factor too. Because batteries, big plane, a lot of batteries to get it up, it won't stay flying as long.
It's been my field week for the engineer, and he makes us do a lot of research about it. And like I say, I'm glad you asked me that question. So that's how would he like to be? Because the airplane is actually built by us, but we also have to his recommendation how it's going to be built and how long that plane is there.
Because duration in flight, what kind of plane? How much power is it going to take to how much does the plane weigh? How much power do you think you're going to need to keep it going, and how long? All of those things are going to factor into what kind of power you might want to use on it. Weight,
Power.
flight duration,
Acceleration.
flight duration. How long you gonna keep it flying?
Acceleration.
You want to know. I assume that speed's not a big deal.
It did good in the Cup. Remember that?
I don't know.
Speed in large measure is going to be a function of the weight of the airplane, because the heavier the airplane, the faster it has to fly to develop the appropriate amount of lift to overcome drag and gravity.
So you don't mind if I take note at all?
No.
This is very good stuff that we need to learn.
This is basic aviation kind of stuff.
Yeah, but I never know anything about aviation, so basically that's the thing we have to go down.
I wished I could remember the name of the program. There's a program, I think it's called MotoCal, and it involves determining how big an electric motor you need, given the number of square inches of the airplane, the weight of the airplane, and other flight parameters like how fast you want it to fly, how long you want it to fly.
So this is actually mathematics. You gotta do a calculation.
Exactly.
Yeah.
There's a website. There's a couple of websites. One is RC Groups, rcgroups.com, and rcuniverse.com.
I would suggest rcuniverse.com, and when you go on to that website, they will actually give you different rooms for electric powered, and you can go on and you can ask some basic questions about, engineering student, the task is to build, design, and here's the parameters. I need some initial guidance on where do I go to determine the size of the motor, the size of the battery pack, the size of the propeller. And then there's guys who would be able to give you construction hints on, well, you need this size of wood versus another size that would be good for powered, but because electric motors don't have the vibration that a gasoline powered airplane would have, you don't need to build the structure as strong for an electric powered airplane, so you can use smaller size wood, which reduces the overall weight of the entire package.
Are both of those websites are good to ask those kinds of questions? Also, they'll have rooms which are builders' rooms. They have different rooms for different things. So there's a gas section that's all gas and nitro. There's another section that's electric. There's another section that's just for builders. And if you go in there, if you're going to ask some of these basic aerodynamic questions, like how much power do I need versus, weight, all those kind of trade-offs, Builder's Workshop is good because there's a lot of people in there that build scratch planes and design planes, and they've worked those problems for years.
Right. Actually, your name's Steve. And Steve, you mind if I ask you? You're saying that the training for flying is at Thursday at 5. And you have to bring your own airplane.
Did you go fly?
Yeah, I just could not provide airplanes for all the students.
I believe I forgot what his name is. The one I just talked about.
Dave.
Dave. Do we have to carry is that actual airplane we can actually buy? He mentioned with the cheap one was $250.
Yeah, that's for sale.
Go on. You can go on towerhobbies.com, and they have ready to fly trainer packages available that includes the airplane, the motor, and the radio already installed. And basically you glue the two wing halves together, you glue the tail surfaces on, find an instructor, charge the batteries, and you're pretty much ready to go.
That's an electric airplane, right?
Those are gas.
Gasoline?
You can get that combination in electric powered as well.
Okay.
Yeah, the one we have for sale is a gas powered.
What's this gas electric? We'll be fine. As long as I know how to fly, 'cause these things are not toys. You know, you actually know how to fly.
Regardless of the propulsion system, flying it is going to be the same for both of them.
Yeah,
Right.
exactly. You get more stick time for training. You'll get more stick time on a gas plane or a nitro plane than you will electric.
With the advent of lithium polymer batteries, that old adage was correct. With the advances in the motor and in the battery technology, the flight duration on an electric, assuming you throttle it back to a reasonable speed, the flight duration on an electric is going to be almost comparable to a wet powered airplane.
Right. I mean, like I say, I don't know anything about UV. It's a good thing that I hit the right club.
Well,
I learned a lot.
I would like to think that most clubs are going to give you comparable information. I'm just happy you chose us.
Now you see that plane that's going out there?
That's a pure trainer.
That's a trainer. That's a Great Plains PT-40. I learned how to fly on a plane just like that. Very, very gentle, easy to fly, real stable. A little bit challenging in this kind of
Tony.
No firing up electrics back here, please.
But that's a typical trainer. You see how the wing has a lot of. You see how the wing has got a beat to it. How the wing is like this. That's called suspension. Like that. That makes it very stable. So that the plane, you let go of it, pretty much goes straight ahead.
This is less stable. When you want an airplane that's aerobatic, you actually want the airplane to be neutral in its stability to almost a little unstable, which facilitates the performance of aerobatic maneuver. When the airplane is too stable, it flies great, but it won't do any aerobatics.
So basically, if you want to put more weight into an airplane, it should neutralize it a little bit.
Well, you have an airplane, okay, and this is the wing right here, okay. This is the center. Let's say this point right here is called the center of gravity, okay. This dashed line represents the axis of flight. Okay, the airplane is flying straight and level in this direction. If you have the weight balanced right on the center of gravity to where from this point to this point, and let's say this is the.
Hi, how you doing?
This is point A. The nose is B, and the tail is C. If A to B equals A to C, then you're okay. If A to B does not equal A to C, then the airplane is tail heavy and it's going to crash. It's going to be extremely unstable. Okay. You can take this same airframe, exact same airplane,
Yes.
and on most airplanes, the center of gravity range is about that far on a model airplane. Okay.
Right.
I can take this center of gravity and I can move it to the forward range, and this airplane will fly okay. It will